the unit circle. All you wanted to know about it. In order to find any point, or the coordinates for any point on the unit circle, use your unit circle. In order to find one of the trig functions on the unit circle, you're going to need to determine exactly what it is that you need to figure out. Some of these will be rather simple, others will require a little bit of work once you've found them. So let's try it out. Simple one here. If you've got sine, that's going to be your y. So if I want to take, let's say I need to do sine of pi over 2. All I'm going to do is look for where pi over 2 is on my unit circle. I scan around. I see pi over 2. Sine is y. Therefore, the sine of pi over 2 is going to be whatever my y value is at that point on the unit circle. Just 1. Similarly, I can do cosine of pi over 2, and that is going to give me the x value there, which is 0. It gets a little bit more complicated when you look at your tangent. Tangent is y over x. So if you need to find something like, let's say, the tangent of 5 pi over 6, you need to first of all find out where that is on your unit circle. 5 pi over 6 brings us right to here. And as tangent says here, tangent is y over x. So I look at my tangent of 5 pi over 6, that's going to equal my y, which is 1/2, over my x, which is negative square root of 3 over 2. Remember, when we divide by a fraction, we're going to multiply what's on top by the reciprocal of the bottom. So in other words, we take the top is going to stay as it is. This bottom part is going to move over here to multiply. But when we multiply it, we need the reciprocal, which is it flipped. So take negative square root of 3 over 2, and we're going to multiply by, well, the 2 is on the bottom down there, so now it goes up on top. And the square root of 3 is on the top over here, so now it's on the bottom. And this whole thing is still negative. The negative isn't going to change. And then multiply across. So 1 times 2, that'll give us 2 on top. 2 times the square root of 3 will be on the bottom. And this is still negative. The 2's are going to cancel, and we're left with negative 1 over the square root of 3. But we're not done yet. I'm going to copy that. I'm going to move that negative 1 over square root of 3 down here, because we've got to clean it up. We cannot leave a radical on the bottom. We've got this square root symbol here, and that radical will not stay. Okay, we just can't leave it in that form. So in order to get it to something that we can use, we're going to multiply by square root of 3 over the square root of 3. Any number divided by itself is 1, so really this is just 1 in another name. The value of this is 1, so we can multiply it by this, and it's not really going to change anything as far as how much that number is, what its value is. All it's going to change is how it looks. So we're multiplying fractions, we just go right across here. 1 times square root of 3, we get the square root of 3 on top. On the bottom, square root of 3 times square root of 3. 2 square roots times each other, that's going to just be whatever is under that square root bar, under the radical. And then this is still negative, so we're going to put the negative down there. This is an answer that we can work with. So your tangent of 5 pi over 6 is just going to be negative square root of 3 over 3. Again, all we did was we took our y, which was on top, and we divided it by our x, which we put on the bottom. And we just had to do some multiplying of fractions. That's it. If you're looking for something like secant or cosecant, let's do secant of, how about pi over 3? This line here, get a new one. Secant of pi over 3. We look at our unit circle, and secant is 1 over x. So we're going to look at our x right there, and that is 1/2. So this is going to equal 1 over 1/2. This, again, we're going to use the same trick we used before. We're going to take what's on top, put that on the left. We're going to multiply by the reciprocal of what's on the bottom. So this 1/2 moves over here, and we are going to flip it. So now the 2 goes on top, the 1 goes on the bottom, and 1 is just really 1 over 1, right? It's just the same, another way of saying 1. It's just 1 divided by 1. We multiply straight across. 1 times 2 gives us 2. And then on the bottom, 1 times 1 gives us 1. So it's just 2. Or if you want another way of looking at it, if, again, remember secant is just cosine. Really, it's cosine flipped. Cosine of pi over 3 is 1/2. So if you're going to go from cosine to secant, all you really have to do is take what's on the bottom, put it on the top, and take what's on top, put it on the bottom. That's what that guy is. So if you do a few of these, you might see that shortcut pop up. You can do it that way. If you like to do it the long way here too, that works. But after you look at it for a while, you might see the pattern. Okay? The other thing that you might have to deal with for unit circles, you might have something like, oh, let's say the sine of 720 degrees, because degrees are on the unit circle here as well. They're all marked. If you've got sine of 720, this clearly is not on the unit circle. Unit circle goes up to 360. We can't go any further than that. But what we can do is we can subtract 360 from this. And why 360, you say? Well, 360 is a total circle, right? If you subtract 360, then you're just going all the way back, one rotation, and you're going right back to the same spot you just left. So you're going to have the same coordinates here. The coordinates are going to be the same if you do a full revolution and you come back, because that's a full 360 degrees, or it's a full 2 pi if you're dealing with radians. We take 720 and we subtract 360, we're left with 360. So the sine of 720 is the same thing as the sine of 360. And 360 is on our unit circle. And we see our y-coordinate here. It's 0. So the sine of 360 is just going to be 0. Same thing happens with radians, although you might have something a little bit trickier. So let's say we want to do the cosine of, oh, how about 9 pi over 4. Okay. 9 pi over 4, our limit for size is really 2 pi. We can't go any bigger than 2 pi. Otherwise, it's not going to be on the unit circle. And this, the biggest one we've got here is 7 pi over 4. Looks like this 9 pi over 4 is not going to be on the unit circle. So we're going to need to subtract 2 pi from this in order to get it to fit. So let's take this 9 pi over 4 minus 2 pi. But I can't just subtract 9 pi minus 2 pi because they don't have the same denominator. We've got to have a common denominator in order to subtract. So I'm going to make this 2 pi over 1, because that's just another way of saying 2 pi, and that way we've got some sort of denominator there. I'm going to multiply this by what my denominator is for this first term. That's 4 4. I'm going to multiply by 4 over 4 because any number, again, divided by itself is 1. We're not changing the value of this 2 pi. We're just changing the way that it looks a little bit so that it'll interact and we'll be able to subtract it from this 9 pi over 4. This will then become 9 pi over 4 minus 8 pi over 4. And now that they have common denominators, we can subtract. 9 pi minus 8 pi will give us pi over 4. And pi over 4 is on our unit circle. We look right there, pi over 4, and we're looking for cosine, so we look at the x. That's square root of 2 over 2. So we can say that the cosine of 9 pi over 4, this is the same thing as the cosine of pi over 4, which is, as we looked up, the square root of 2 over 2. Similarly, sometimes you might have a something that's too small. Okay, so let's say we've got sine of negative 3 pi over 2. In order to find this on the unit circle has no negatives. So just like we subtracted 2 pi here, we can add 2 pi. We're going to add, let me start a new line here. Negative 3 pi over 2. We're going to add 2 pi. Again, we've got different denominators here, so we need to make a common denominator. I'm going to multiply by 2 over 2. This becomes negative 3 pi over 2 plus 2 pi times 2 gives us 4 pi over 2. This negative 3 pi plus 4 pi, that'll just give us pi. The bottom denominator stays the same, over 2. So the sine of negative 3 pi over 2 is going to be the same thing as the sine of pi over 2. And if we look on our unit circle, that's just going to be 1. Sine of pi over 2 is, the y value there is just 1. In the end, you always want to make sure that whatever angle that you're going to have, okay, let's just call this angle theta. Okay, this is theta. We're going to use this a lot for angles. That this theta has got to be greater than or equal to 0 and less than or equal to, if you're doing degrees, 360. That's for degrees. If you're doing radians, where pi is involved, then you've got 0, that's less than or equal to theta, and it's got to be smaller than 2 pi, otherwise it's not going to be on the unit circle. So if you've got anything that's too big, you can add or subtract 360, and you will get the same result if it is in degrees, or you can add and subtract 2 pi if it is in radians. And that's it. This, combined with your knowledge of the trig functions on the unit circle, should allow you to do any unit circle problem that you come across. So practice that, and I think you will do well. Good luck.